Okay. All right, so what I would like for you to do, this can be a point of confusion. So I want you to read problem 10, and then I want you to read problem 12, and I want you to tell me what the difference is, because they are very different problems, and they're going to use very different formulas. So who can tell me what the difference is between what's happening in problem 10 and what's happening in problem 12? What is the big difference? Emma?
In problem 10, it's going to be a present value of annuity, and in problem 12, it will be a future value. And also in problem 10, it's compounded quarterly, and in problem 12, it's compounded monthly.
Okay, so yeah, we got a difference in the compounding, but more fundamentally, actually, no. What is Emily doing? How is Emily saving? What is Emily doing?
She's putting in $500 at the end.
She's putting in $500 every quarter, right? How many trips to the bank is Emily making? 4 times a year, right? She's walking into the bank and handing them money 4 times a year. She is making payments. Now, look at problem 12. What is Joelle doing? How many times is she going into the bank?
Every month.
Joelle's not going in every month. How many times is Joelle going in? Once. She is making a single payment. Right? She's walking into the bank one time, handing them a chunk of money, and then she's done. Kids, you've got to see the difference between those two problems. Number 12 is a regular compound interest formula. This is number 12. On the exam, there's no partial credit for our formula. You've got to know which formula to use. So you've got to read the problem carefully. If it's a one-time deposit, walk into the bank and hand them the money and you're done. This is the formula. Okay? So this is number 12, Joelle. She's investing $8,000. Her interest rate is 0.09. Compounded monthly would be 12. How long will it take? So I do not know what T is, but I know I want to basically double my money. I want to end up with $16,000. Does that look okay to everybody? All right, so how do we solve it now? You're going to divide by 8,000 first. You got to get rid of that number. Always, always, always get rid of that extra number. So we'll just have 2. Now what? We're going to have to ln, or log. ln or log, you do a regular log somehow, because we're solving for an exponent. So when I log both sides, this is going to come out in front. So the log of 2 equals 12t, log that parentheses. Alright, so I'm going to go ahead and put in the log of 2. Now what do I need to do? I'm trying to get t by itself. So what do I need to do? I'm going to take the log of 2 and what? Divide it by 12. I can do that. Alright, so I've divided by 12. That's gone now. Now what?
We need to put up with the log.
I need to divide by the log of that stuff. What'd you come up with? Wait a minute, let me try again. That's not what I got. Let me try again. Yeah, that is, yes, you're right, better what I did for 7.73, and that would be years. How long will it take? It'll take 7.73 years.
How did you get rid of the 12?
Divided by,
So then how did you hold on?
I just did log 2 divided by 12. Now, why did we use that formula for this problem? Because it is a one-time deposit. Future value and present value rely on payments. If you are not making payments, then you aren't going to use future value and present value. They must have payments involved. Okay? So let's go back to number, wherever we started, number 10. Are payments being made in problem number 10? Yes. Yep, every quarter, no matter how often the payments are made. The fact is, payments are being made. So this is going to be either a present value or a future value. If there's any kind of payments being made, you're either doing present value or future value. Okay? So what's happening in this problem? In problem number 10? Are we paying off a loan? Nope, we're saving for the future. So this is going to be a future value problem. So I'm going to write down my formula. Okay. Now, Emily makes a $500 payment. R is the payment, so 500 goes in there. The interest rate is 0.0788 divided by 4. Because it's quarterly, this one's quarterly. And remember in this formula, N is the total number of payments she's making. So she's making 4 payments a year for 20 years. So that's going to be 80. And then what is the that's going to give me the value of her fund. All right, so look at that. follow why all of those numbers are in those spots. Alexis?
Why is 80 that?
Huh?
Why is 80 that?
80 is the total number of payments that are being made. She's making 4 a year for 20 years. So that would be 80, right? Am I gonna need logarithms to solve this one? Nope, I'm just gonna type it in however I can do it. So I like to start right here with that parentheses. That's how I do it. You don't have to start that way. Somebody shout it out when you get it. It's a pretty high interest rate, so she's got a pretty good sum of money. Is he?
Okay, wait, I don't know, never mind. I don't know, I got a certain number, but I don't know if it's right.
No.
95,000.
It's 95,483.39. So if I review, if you're having trouble getting that, put parentheses, 1 plus 0.0788 divided by 4, close the parentheses to the 80th power, subtract 1. It equals, divided by, now that's gotta be in parentheses, that could be a problem. You gotta have that in parentheses. And then take that answer times 500. Now, one answer that was tossed out was 23,000, and I just unequivocally said no, that can't be right. How did I know that the answer couldn't be 23,000? How did I know that?
If you're dropping off 580 times. then-
Exactly. If you're depositing $500 80 times, that's more than $20,000, right? 40,000. So yeah, we need to have at least 40,000 because that's how much money we put in. Okay. All right. So now what I want you to do is look at one more problem. Let's look at number 11. And let's figure out what formula we're going to use for problem number 11. Okay? So, what do you think? Read the problem carefully. What formula do you think we're going to use? Present value. Kids, are there payments being made in the problem? Is the word payment in the problem? Yeah. We're making payments. Whenever we're making payments, it's either going to be future value or present value. Not negotiable. If you're making payments, present value, future value, one or the other. So then you just got to figure out what's happening here. Is Gendo saving for the future, or is Gendo paying off a loan? He's paying off a loan. So that's present value. All right, so here we go. Gendo obtains a 30-year, $86,000 house loan. So the value of the loan is $86,000. The interest rate is 0.0875. Monthly payments. All right, how many payments am I making? This is a 30-year loan, and I'm making monthly payments. So what's my end? Yep, negative 360. In this formula, remember, that's a negative exponent up there. We gonna need logarithms? Nope. Nope. We're gonna need to figure out what this is, and then divide 86,000 by that. So again, this is my style, doesn't have to be yours. I'm gonna type in that numerator, and I'm gonna type it exactly the way I wrote it. So 1 minus parentheses, 1 plus 0.0875 divided by 12, close parentheses, raised to the negative 3/60th. Then I'm going to divide that number by parentheses, 0.0875 divided by 12. And then after I have that done, I'm going to take 86,000 and divide it by second answer. Whoa. Oh, I made a mistake. Look, I gotta start over again. I typed in negative 30 instead of negative 360. So, tell me what you get. What'd you say? Yeah, 76, 56. Okay? Now, I'd like you to get out I gave you right a long time ago, I gave you a review sheet for the chapter before I realized we weren't going to be able to get a text in. So you've got it's got 3 pages. We're just going to do a few random problems here. We'll do a couple and then a little one.
What's the negative 360?
Well, it's negative because the formula, it's the number of payments you make. 30 years, 12 per year. Okay, so what I'd like to do now, when I stapled it together, I guess we call this the front page. I don't know. It says chapter 3 review sheet. Okay. And I'd like you to look at part 8, which is all these word problems. Problem B. Let's write down the formula that we would use in problem B. Tell me the formula you're going to use for problem B. Okay, guys, the way I gave you the packet, the staple together, it's that right on top. It's right there. So what formula am I going to use for problem B? Abby? Her formula, absolutely. And how do we know that we're gonna use PERC.
Because it says, constant and.
Well, it's a bacteria problem, right? PERT, every formula we have is financial, money, except for PERT. PERT can be used for money, but PERT can be used for other things. So if it's a non-money, it's going to be a PERT. All right, it's continuous growth. Organisms are continuous growth, but any non-money is going to be a PERT. Okay? All right. Now what about C? We're going to come back and do these as one. Let's just see if we can figure out which formula to use. C. Which one? Compound interest. So that's going to be that. How do I know it's that? What's missing? What's not mentioned in the problem? What isn't happening in the problem? No payments. It's a one-time investment. What about E? What's E gonna be? Present value. Why is E gonna be present value? Two things. Number one, are payments being made? Yep. And number two, are we paying off a loan or saving for the future? We're paying off a loan. That's present value. So we're making payments. That tells me I'm either PV or FV. And then in this particular case, I'm paying off the loan. Okay? So when we come back from lunch, I want to see if they... All right, so I need you back in your seats at 20. A little bit shorter lunch because they shortened the time. Back in your seats at 20.